So in this case, we are going to consider a typical exam revision as a continuation from the previous part that we had managed to work with the paper 2, which is the section A. And like I said, we are going to finish up the section B. I still need some of the materials, which is for us to work out some of the questions which we have on our section B. So in this case, we are going to consider the paper 1 so that we can see where we had challenges and to prepare for other things in actual sense. If you know that you are done with this session, you move on, start to prepare for your A level. If you know that it is not well, then you start also to prepare for the November exams. So that's it. We just need to prepare for everything that we are going to work on. So that is our paper 1. We are going to work on it. We just hopefully, we just hope that everything is going to be well in terms of the time, finishing of the paper. That is it. So in this case, also, I want to thank Mets Guardiola. So that is, I don't know if we, most of us actually have came across him. So in most cases, if we consider the question papers that we have, we also try by all means to work together. So we need more question papers, more revisions. So if you are part of our mathematics revisions, so make sure that you check the description of the channel so that you can access the WhatsApp groups. I think if you check, there are actually 3 groups for now. We do not know with the time how many are going to be there. So you just check which one is having space. Or sometimes you might check the first one, it is full. The second one is full. Then you try to attempt for the third one. You can access these WhatsApp groups through the links that are there on the description of the channel. So once you're part of the WhatsApp groups, you can contact him for what? For the question papers, any subject that you're doing. So that can help you for the studies. We are talking about the study material because in most cases, we are busy, guys. Cannot be there focusing on the provision of videos, provision of study materials. So if you need your study material that is for your examinations, prepare for your examinations as an individual. You need to get hold, you need to contact him so that you have necessary equipment, necessary resources, question papers, textbooks that you need for the subject that you're studying. That is the most important thing. Do not just study without a textbook, without even question papers that you refer to. You do not have any reference. You must have textbooks, question papers, and also the videos as we have them here on YouTube, trying by all means to work on our revision. So that's it. We are going to quickly go through the questions, and for some of the other topics that are not yet covered, let us also communicate on the comment section so that we can add those topics. It's unfortunate that it's quite a busy year, so but we shall try by all means to add each and every topic that is missing. So as we do understand our paper 1, no calculators, guys. No calculators. So meaning to say, as an individual, train yourself not to use the calculator in this paper. So we are given neither mathematical tables, no slide rules, no calculators may be used in this paper. Number 1A, it was to express 4,560 in standard form. from the ordinary form number that we are given, can we express this number in standard form? So we are given, that is 4,560. So remember, in standard form, a times 10 to the exponent of n, where a is a number between what? 1 and 10. So you're supposed to move the comma from here until we have a number which is between 1 and 10. So let's move, that's going to be 1, 2, 3. So the number that we are going to have is supposed to be 4,56 with a 0 there, this one. But it's not important, this one. So you can ignore that 0 and multiply times 10 to the exponent of what? The n, this one, is representing now the number of commas that you moved. That is 1, 2, 3, remember? So that's times 10 to the exponent of 3. So remember, you started with what? A whole number. So at the end, we must have this exponent as a positive. If you were given a decimal, if you're working with a decimal, you must have your exponent now as a negative, the power as a negative. So we're going to move the commas 1, 2 like this. So it will be 4,56 times 10 to the exponent of what? How many commas did you move? 2. But with a negative now, because you're dealing with what? With a decimal. So let's note the difference when you are having a whole number and when you've got this decimal part. So that was our question on number 1A, that is for 1 mark. Okay, let's move on. The B part we are given, it is given that 2 times 10 to the exponent of 3 plus 1 times 10 to the exponent of 1 plus 3 times 10 to the exponent of x plus 5 times 10 to the exponent of y is equal to what? It's 2013.05. This is what you're given, where x and y are integers. X and y are integers. From this information, find the value of x and the value of y. It is given that it is a statement that you can consider to say, from this number that I have here, how was it rewritten in this format? So if we try to figure out this type of a question, guys, it's just a direct question. Just try to figure out. You see that 2 times 10 to the exponent of 3 is 2,000. Remember, times 10 to the exponent of 3, I've got what? 1,000. So meaning to say this part here is representing 2,000. I want you to see something, because we want to have it in the normal way, like the ordinary way that we're given there. Plus 10 to the exponent of 1, which is 10, times 1, which is 10. Plus, we cannot simplify these two since they are raised to unknown exponents. Okay, so let me just rewrite as they are. To their corresponding unknown powers or exponents there. So the question now is, how can we determine this x and y? If you are to consider this properly, let us add these two. I want you to see what is happening here. So here they were just trying to play around with our minds here. They were just trying to play around. I want you to see something here. If you check this 2,000 and this 10, these numbers can be combined together. We can add these two because we do not have any x there. All right, adding these two, we're going to obtain 2010. We are adding the two numbers, 2010. Then if we consider this section that is remaining, how can we rewrite? Because we want to have the same thing as what we are having there. So the question is, how can we have that? So as a continuation, you just need to figure out the 2010 that we have here. If we consider this part, we have got 2013. The difference, what is the difference there? The difference is going to give us the part that is remaining, because we want to know the part that is remaining and also the decimal part. So let's work out with the 2010 from this 2013. So let's subtract minus 2010, that was going to give us what? A 3. So if we consider this is a whole number, this one. Remember, I was referring to the whole number part before. If you are given 10,02, we've got the part of the whole number, then we've got the decimal part. So on the whole number part, the 2013, the remainder that is remaining there is this 3 that we have from 2010. Remember, we've got 2010 that we combined here on the left-hand side. So this remainder, which is 3, we want to figure out now the value that is corresponding to that 3, because we have considered this part, we have added this part. So out of this part that is remaining, which part is going to correspond to 3? Definitely it is this part that is 3 times 10 to the exponent of 10. You study this part. We can see the part of a 5. Definitely this one is going to correspond with the decimal part that is remaining there. So meaning to say, in order for us to have this 2013, we need a remainder here. We need a 3 to the 2010. So that is the one that is going to correspond here. So if 3 times 10 to the exponent of x is equal to 3, what is this x that we have here? Already we can see that the 3 is there. So which number are you going to put here so that you remain with a 3? Our x was going to be what? A 0. Remember, any number to the power of 0 is what? It's 1. So 3 times 1 is this 3 that we have. Or it's just an equation that you're going to formulate. 3 times 10 to the exponent of x is equal to what? This one. The whole of this part must give us what? The 3 that we want the remainder. So what is x? Divide by 3, divide by 3. That's another way. So we are going to have this one, 10 to the exponent of x, which is equal to 1. We are back to our basis, guys. Remember, 1 is same written in the base of 10 as 10 to the exponent of what? Of 0. So x is equal to 0 as the bases are the same. So that is it. Just like that. So the number there representing x is supposed to be what? A 0. So that if you simplify this part here, if you simplify it, you are supposed to have what? A 3. So the value of x is the one that we need. We already have the number there, which is 3. So the question is, from the presentation that we are given, kubva pamanyorero azvakaita, tingadzoka sei pana 3 mumwe chete? X anofange ari ani usho kuti tidzoke pana 3 mumwe chete usho. X ndiani? Ndozvingobvunzwa. Pama integers ese value yatingaisa pana x up, tikanomugadzika pana x up, tinodzoka pana 3. So if you put a 0 pana, tikanogadzika 0. 3 times 10 to the exponent of 0. Zvangofana ngoti 3 times 1, 3 times 1, which is what? Which is the 3. So x apangarani are 0. So that is the idea of how you attempt this typical question. So it was just like a study type of a question. You study what is happening on the question, then you attempt it. So to find the y part, remember we are done on the whole number part. 2013 tapedza naye because tikati 2010 plus this 3 tikuwana 2013. So we are done with the whole number part. So meaning to say, by default, what is remaining is the decimal part. Zviri kusara ku left hand side, 5 times 10 to the exponent zasara ku left hand side. By default, zvatofanana ne decimal part iri kusara kuno right hand side. So chi chasara ku left hand side. That is what? 5 times 10 to the exponent of y, which must be equal. Anonofanirwa kunonofanana nezvikuno. Sekufanana kwaita 2013 na 2013 wataona ku. Nofa the same thing. Saka tikanotora 5 times 10 to the exponent tunofanadza nani 0.05. Remember we have removed this one. Sa akunzi 0.05. So it's just a study type of a question. By just looking, how can you, like the question is, what is the value of y? The value that you substitute here in place of y so that you obtain a decimal, which is called 0.05. Understanding our exponents was very, very important. That's a negative there. For us to have a decimal, it's a negative exponent, but it's negative what? So that we have got 0.05. Is it going to be -1? Is it going to be -2? Is it going to be -3? That's 5 times 10 to the exponent of negative. It's just like we are expressing this one back to the standard form. We're just rewriting in standard form. So that's 5 times 10 to the exponent of what? -2. All right, 1, 2. 5 times 10 to the exponent of what? -2. So meaning to say this presentation here is the same 5 times 10 to the exponent of y. 5 times 10 to the exponent of what? -2. So y is -2. So I don't know if you are together to answer this question. There were so many ways to answer this question. If you check, there are so many ways. It is about your understanding. So I just hope this understanding, it can make all of us to understand despite like the way that you understand. So many ways. So just try to figure out how you can attempt it. It was just like a play around type of a question where you play around the information that you are given. Remember paper one day kuti chero chitongoziva kuti answer ndi 2 ndokuonera kuti x is equal to 2 what paper one, guys, is just the way that you understand. Number 2, in the diagram P, L, Q, so from this point P to L to Q, it is a straight line. So we are given this one is a straight line. And from this information, the line LM is parallel to NR. So these two lines, they're parallel as we are given. The line LM, this line bisects. So there is a statement there that is very, very important. The line LM, as we are given it, it bisects QLN. QLN, this one, from Q to L to N, like this. It bisects. What is to bisect? To bisect is to divide into 2 equal parts. So this line LM, this one, is dividing this angle into 2 equal parts, meaning to say this angle and this angle here will be exactly the same. So if this angle is 50 degrees, by default, this one is also 50 degrees. Because these two, they are equal. The line LM has divided the whole angle into 2 equal parts. That is the meaning. Then we are further given that this angle is 50 and this one is X and the other one is Y. They find the angle marked, all right? So the first part of this question was to find the angle that is marked X. The angle marked X. So if we are to consider, this is where we have got our X on the diagram, and this X is on a straight line. Remember, we are told about the straight line here. PLQ is a straight line. So angles on a straight line add up to 180 degrees. You're done. So meaning to say, to find X, we simply add these angles which are on a straight line. That's X plus 50 plus 50. Remember, we said these two angles are equally the same. That must give us 180 degrees angles on a straight line. So that's it. We can have X from there. So X 50 plus 50 is what? 100, which is equal to 180 degrees. So to find X, that's 180. Take the 100 to the other side. That was going to be what? Minus 100 degrees. So X is equal to 80 degrees. Just like that. angles on a straight line. They add up to 180 degrees. So you can simply formulate an equation straight. X is equal to 180 degrees minus the sum of the two angles. Since you understand this, 50 plus what? 50 plus 50. Straight like that. So the way that you understand, guys, at the end is important. All right, the other part of the question, it was to find the angle that is marked y on part B. The angle marked y. We have got the angle x. All right, we calculated this angle, which is 80 degrees. Okay. What about the angle y? From the parallel line concept, we are given that these two lines, they are parallel. What do you understand about the angle, this one, the 50 degrees, this one, and this angle from the lines which are parallel, where we form an F angles, corresponding angles, the ones that form an F, corresponding angles, they're equal. So if this angle is 50 degrees, this is also 50 degrees. So if this is 50, we've got 50 there. As we can see, we are forming an F here, all right? If we are to consider like this, we are forming an F, this one. F angles, corresponding angles, the ones that form an F, they're equal. So it's all about your theorems there, knowing the theorems that are under the parallel lines. So that is it. Angle y is equal to what? 50 degrees. Just like that. So we are going to consider the other part of the question. On question number 3, we are given the temperature reading in degrees Celsius at noon over a period of 6 days. The number of days is given, and these were the temperatures in what? Degrees Celsius. Then we are told that the mean temperature for the 6 days was 30.5 degrees Celsius. The mean, you are told about the mean. Remember, mean is equal to what? The sum of terms over what? Over the number of terms. If you're asked to calculate the mean, we are simply about what? The sum of terms over the number of terms. So we are given the mean. Then the question is calculate the value of x. So if you understand this, you're simply going to form an equation from this understanding that the mean that I'm given here, which is 30.5 degrees Celsius, is equal to what? The sum of terms. I was supposed to add these terms, 30 plus 29 plus the x that I'm given plus the 31, okay, plus the 30 that I'm given, plus this 32. The sum of these terms over the number of terms. How many are they? The number of days. We are given the mean for the what? 6 days. We have formed an equation from that statement alone, that statement of mean. It is not every question that you are given, calculate the mean. They can give you the mean, then from the understanding of the mean, calculate the unknown value. So that's it. Simply add the numbers. That will be okay. Here you can even cross multiply, guys. You can add the numbers, but at the same time, can as well cross multiply. 30.5 times 6 was going to give us 183. Make sure that you multiply properly. Then on this side, you add these numbers together. So that was going to give us a sum of 152 plus x. So to find x, take the 152 to the other side of the equation. That was going to be 183 minus 152, which is x. So that is 31. So just like that. So remember, this is a temperature in what? Degrees Celsius. So do revise as many questions as you can and also verify your answers as well. If we are having the same answers on the sum, remember, guys, we are adding there. So make sure also you verify your answers. So what to consider? Question number 4. For A, we are given solve the inequality. Solve for x. Just like an equation, we solve also inequalities. We're supposed to solve. So how can we solve this? X minus 8 is greater than 4x plus 1. So there you've got options. It's either you're going to take the x to the right-hand side, or you're going to take the 4x to the left-hand side as you are collecting your like terms. It was in your hands. So in this case, I'm just going to take the 4x to the other side. So that's x minus 4x is greater than the minus 8 to the other side of the inequality. The moment it crosses the inequality sign, must change. So this is minus, it's going to be what? Positive 8. X minus 4x, this is the same as what? 1 minus 4, which is what? Minus 3x is greater than 1 plus 8, which is 9. So to find x, we are going to divide by what? Negative 3. And take note, as you divide by the negative, the inequality sign reverses, or the inequality sign what? Changes. Pauno divide a negative chat. Make sure that inequality, need to say, change. Saka zvikuru what x is what now? Less than. Remember, it was a greater than, now it's less than. 9 divided by negative 3, that was a negative 3. Zvato change. The inequality sign has changed. Must be very careful whenever you deal with a negative, of which you could have avoided working with a negative. Taikwanisa kutozvi avoid zvema negative. Taizviita sei? Okay, we could have avoided this by taking this way. X minus 8 is greater than 4x plus 1. Since we can see that if we take the 4x this side, it will be negative. And definitely we are subtracting a bigger number from a smaller one. So apana imwe nzira kutobudisa negative chat. We are going to have a negative there. So to avoid it, we are going to take the x to the right-hand side, so that we are subtracting a smaller from a bigger value. At least we are going to have what? A positive there. We are avoiding to have a negative on x. All right, let me just write here. Avoiding. We are just trying to avoid. So that's avoiding, or avoid having. Okay, just avoid, or avoiding here a negative. All right, on x, on the variable that you're given. X is the variable. So we can take the x to the other side of the inequality. So meaning to say, what were we going to have here? The inequality sign is still the same. We are just taking x to this side. So it's going to be 4x minus x. On the left-hand side, what is going to remain? The minus 8, which was already on the left-hand side. Remember, there was a minus 8 there. Then what about this one? We take it to the left-hand side. It's going to be a negative there. So that's negative 1. So this is what we have. What we are simply trying to avoid here is having what? A negative on the variable. So minus 8 minus 1, that is minus 9, is greater than what? 4 minus 1, which is 3x. So as we can see, the part of the variable is having a positive. So if I divide both sides by 3 like this, the inequality sign is not affected this time. It is not affected. We are working with a positive. The inequality sign as it is, it will remain as it is. So meaning to say 3 into minus 9, that's what? Minus 3. So minus 3 is greater than what? X. So the question is, this presentation and this one, are they exactly the same? Are they exactly the same? It is the same thing. We are still having the same situation that x is less than minus 3. X is less than minus, x is being pointed by minus 3. It is less than minus 3. So someone who is writing this way, Someone is writing this way, simply having the same thing. X is less than what? X is less than, X is being pointed. X is less than -3. It's one and the same thing as we can see. So that is how you can have these questions. It's actually in your hands, as you can see. So this June exam, guys, it was actually straightforward. You just needed to understand more of your basics. Then the B part represent the solution in A on a number line. Remember, the solution that we got in A states that X is less than what? -3. So the question is that represent this on a number line. So our number line representing the X values, what is important when you are given -3 is just to indicate maybe just a 0 here. Then are we going to have the negative on the left or on the right? So negative will be on the left side. That is -3 here. X is less than. That's what? Unshaded circle at -3. Then which values represents values that are less than minus? This is -4, -5, -6, -7. All these values, they are less than -3. So that is where we are going to have what? The X values you indicate with an arrow that side. That is the condition. You have your number line. So this was a direct question again. Then another part, number 5, evaluate A 0,2 by 0,35. Remember, you do not have a calculator. That is why they are tempting you with these questions to check your understanding on the decimal. Okay, so let's multiply. We can even start with this one, which has got more decimals after the comma. That's 0,35 times 0,2. Remember, A times B is the same as B times A. Product, if you're multiplying this one and this, is the same as I can start with this. So it will be easier if I just have one decimal place than this one that has got 2. So let's multiply 2 times 5. That was going to give us what? 10. So we've got 1 aside. 2 times 3, which is 6. Then we add this one. So 6 plus 1, that is 7. 2 times a 0 there. If there was a number which is maybe a 4, a 5, you were going to multiply. That's a 0. 2 times it, that's a 0. Okay, so how many decimal places are we going to have on this answer? From what we had on the question, here there were 2 and here 1. So 2 plus 1, that's 3. So we're going to add 1, 2, 3. We're going to count them in 1, 2, 3. So we are going to have 0,007. 070. We are supposed to have 3 decimal places after the comma as we have this 1, 2, 3. But this 0 that we have is not important as long it is not between significant values, important values, important digits. We can ignore that one. So meaning to say on our final answer, we can have it as what? 0,07. It's fine like that. You can ignore this 0. So that was it on 5A. Then considering the B part, we have got a division there. So make sure that you change these mixed fractions to improper fractions, right? Multiply, then add 5 plus 2. That was 7 over 5 divided by, multiply here, then add 3 plus 2, which is what? 5 over 3. A very tempting question indeed, because most of you here were tempted to cancel here. But that is impossible. We are having what? A division. Remember the principles that we are working with. For a division, I'm supposed to introduce a multiplication. No matter how you are tempted there on this part. So 7 over 5, you introduce a multiplication times. The moment you introduce a multiplication, what happens? You invert the second fraction. Tinonopesanisa. Repa second fraction. Just like that. So that's 3 over 5. so that you can multiply the numerator to the numerator, the denominator to the what? Denominator. As we can see, there is no relationship here between these numerator denominator that we can cancel this time. Hapana pekuti ngano cancel. So if you do not have anything that is common, do not force this question where you end up canceling the 5 and the 5. No. Apasi pese pekuti nongosangana nepano ponono cancel. Apasi pese. So if you've got this 8, multiply the numerator to the numerator together, that's 21. The denominator to the denominator, which is what? 25. You're done. So that is how you can attempt these typical questions for a division. So remember, paper 1, they are testing you. Paper 1. Like I always say, when you're answering questions, make sure you work with when you're answering questions, make sure that you understand what you are dealing with, the type of question that you are given there. All right, if we are to consider another part, all right, that was, let's say, the square root of 0,0081. So we have got the square root of a decimal, so many ways. We can find the square root of 81, which is 9. Then you ask ourselves, how many decimal places are we going to have on our final answer? Since the original one is what? 1, 2, 3, 4. We have got 4 decimal places. If you are working with a square root, the number that is inside of the root is a 2. So what you do is that the number of decimal places, you divide them by the number that is inside of the root sign. If it was cube root, you divide by 3. So there is square root, meaning say there is 2. So that's 2 into 4, meaning to say what? 2 decimal places. Our final answer must have 2 decimal places. So this is 1 decimal place, 2 decimal place. So it's going to be 0,09, which you can write as what? Plus or minus. Remember, when you're working with the square root. So you can work direct on that square root. Or some, they can change this to a fraction. So that's the square root of what? 81 over what? How many decimal places? 1, 2, 3, 4. Meaning to say this is what? 10,000. Where you can determine now the square root of each, because you understand the square root of all numbers better. When they are given like this, you can determine the square root of 81 on its own, of 10,000 on its own. So the square root of 81 was going to 9. Of 10,000, we've got 2 here, 2 here. So that's what? 100. So divide, that's 0,09. But remember that the square root of n number plus or minus, you can have the plus or minus part, or you can leave that part on your final answer. It was not an effect. So if we are to consider another part, all right, if we are to consider, in this case, we are given the temperature readings at different time. First one, that is 900 hours, 1600 hours, were given as -3 degrees Celsius and what? 18 degrees Celsius, respectively. It is assumed that the temperature was rising at a steady rate. For those who are doing physics, science, something, as long as it's about science, guys, you understand this rate. Besides to say a steady rate, the moment you refer to a rate, the rate is something that you must consider per unit time. You are considering the rate of volume. It must be volume per unit time. Is it area? Must be area per unit time. So in this case, what are we referring to as a rate? The temperature was rising at the rate of temperature. So the rate of temperature, it means we are going to be talking about what? The degrees Celsius that we have as part of our temperature per what? per unit time. That is what we call the rate. So that will be temperature per unit time. Per unit time. Meaning to say you must know the temperature that was taken in that time frame. Okay, anyways, we're going to see that one later on, but be very careful of that. So A, the temperature range. Find the temperature range. As long you're dealing with range, maximum minus what? Minimum. So in terms of temperature, it's maximum temperature minus minimum temperature, just like that. What is our maximum temperature? 18. So that's 18 minus the initial, the minimum, the minus what? Minus 3. So minus, that's a plus. So it was going to give us 21. So this is our temperature range. Maximum minus what? Minimum. Then the question further on B, to find now that rate of what? Temperature. Temperature per unit time. That is why that is why they're saying the rate of temperature change per hour per unit time. And our time is in what? Hours. Once you have the per, this, it's followed by, divided by what is following. Per this, divide by that per. It's per what? Per hour. So this one divided by, that is what they simply mean. So if you are given volume per this, take that volume, divide to that per. You are done. So per hour, that's per unit time. So already the change in temperature is there. We already have this change in temperature, guys. It is from what? From the range. Temperature range is the difference in temperature. So the change in temperature is already there. This one, it is our change in temperature. So the change in temperature, let me just write it here. Change in temperature over what? The change in time. We already have the change in temperature. What is the change in temperature? We got 21. So that was 21 degrees Celsius over what? The change in time in hours per hour. If they said a second, you can work with the hours, since this time frame here is based in what? In hours. Then you can convert to the seconds on your answer. So the question is between 900 hours and 1600 hours. How many hours do we have there? That's the difference. 16 minus 9, that was going to give us what? 7 hours. We've got 7 hours in between. The change in time, maximum again, minus minimum, in hours. So the change in time is there in hours. That's 7 hours. So as we can see, we are working with degrees Celsius. Here we're working with time. So that will be 21 divided by 7, which is 3 degrees Celsius per hour, per unit time, per that hour that you are given. Per hour. Meaning to say each hour that we are going to have, there will be a change of 3 degrees Celsius. Starting from that 900 hours that we are given, there was a change of 3 each and every hour. Per hour, hour. So if we want to confirm that, we can go back there. If there's a change of what? 3 degrees Celsius per what? Per hour. And we've got 7 hours in between. We can find out to say what is the final temperature at the end. From what we are given, the temperature range, from what you are starting from. Temperature at a given point, the temperature at a given time can be determined from the change, from the temperature change that we are given. So the question was a little bit straightforward. Okay, that's it. Then we move on to C, the temperature at 1300 hours. So at 1300 hours, what is going to be the temperature if there's a temperature change of what? 3 degrees Celsius per each hour that you have. What will be the temperature at that point? Okay, this one we can go back to the question, to the original part here, where we had, remember at 0900 hours, where we started, the corresponding temperature is what? Is minus, this is where this one and this one was this. We had -3. I want you to see the logic of this part. What about after an hour? We are now at what? 10:00. Remember, there is a change in temperature per unit time of what? 3, which is positive. So meaning to say at -3, we are going to add 3. -3 plus 3 is what? That's a 0. So meaning to say at 1000 hours, the temperature was at 0 degrees Celsius. We move on. What about 1100 hours after an hour? Because it's about an hour. You add the 3 at 0. 0 plus 3, meaning to say you are now at what? 3. What about 1200 hours? You do the same thing. You're at 3. You add 3. A change of 3, remember, each and every hour. So that was going to be what? 6 degrees Celsius. You move on from 12. We are now at what? 1300 hours. From the 6 that we have, we must add what? A 3. Remember, a difference of 3. So meaning to say, this one was going to give us what? 9 degrees Celsius at that point. From this condition of the change in temperature, where we started from is a negative value. So if we are to consider, to say, because of the change, it's 1300 hours from 09 here, I have got 4 hours. Then I multiply by the time to say 3 degrees Celsius times the time now, which is 4. This was going to give us a wrong value because it was going to give us 12 degrees Celsius in this case, which is 1 unit above of what we calculated. So we must consider to say, where we started here, we started with a negative value. Remember that. So it was best for you to correspond your information now with this. Correspond with your information with this. So, or you can simply work with this idea of your, remember, if you're dealing with those number patterns, because where there's a constant value, you know that for that number of hours that I'm having, I can simply add how many times because there's a difference that I'm given. I started with a certain value, so you can even work it as an equation, this type of equation. You can work with it as an equation. So if we were to continue here up to 1400 hours, we are supposed to have the 18 that we are given. Okay, let's just see. This one is our answer. We are done. I just want you to see. This is 18, 14. So it was going to be 15. Okay. Okay, we need 16. So this was going to be 9 plus 3, which is 12, plus 3. It was going to be 15 plus 3, which is 18. So as we can see, at 1600 hours, we are back to the 18. At 1500 hours, it was going to be this. At 1400 hours, it was going to be this. So that is the idea. But our answer is at what? 1800 hours temperature there. Since there is a change of 3 degrees Celsius per hour, that was the quantity. So if you were to use this one, it was not going to work. You're supposed to subtract the 3. Since we started with a negative, you were supposed to subtract it so that you go back to the 9 degrees Celsius. Because some of us, if we use the red condition that we understand in our physics, it was going to be limited somehow because of that negative. You to refer back. But I just hope with any understanding that you had, you managed to answer this question, guys. Like I said, paper 1, answer the way that you understand. Round off to the nearest 10. So we've got our units here. Remember, that's unit, 10, 100, and so on. So 10. considering 8, it was going to change this 4 into 5. So that's 150, 0, 0, like that. Okay, this one is straightforward, which is 150. Then estimate this by expressing each of these to one significant figure. We had a similar question in paper 2. So we must express these to what? 1 SF. So let's start, guys. 179,35 to 1 SF. The 7 was going to change this one into 2. And the remaining digits are 0. So that's 0, 0. Comma what? 0, 0 again. So that's not important, guys. Okay, times. Okay, the first digit that is important here is the 4. Okay, so 9 can change this 4 into a 5. So that will be 0, 0,05. The following will be what? Zeros there. It's not important. So that's it. Let's multiply. 200 times 0, 0,05, guys. Okay, since it's paper 1, let's multiply. 5 times 0 there, that's a 0, 5. Times this 0, that's a 0, 5. Times 2, that's a 10. So the question is, how many decimal places? 1, 2. So that's 1, 2. So the comma was going to be a 10, 10, 0, 0, which is what? Which is 10. Okay. So that is the idea, guys, of the question. Then if we consider other part, we are given a solid cuboid measures 5 by 2 by x. So that's length times width, then the height. Okay, can call that one the height. Form an expression in terms of x. That expression must have x for the total surface area of the cuboid. Remember, guys, your cuboid concept from the rectangular part. So we can calculate the total surface area. So the question is, how do you calculate the total surface? We've got formulas, guys. 2 times length times width. So you can multiply the length to the width, the length to the height, plus the width and the height, or the height and the width. So that's it. So it was just going to substitute 2 into the length. Remember I said length is 5. So that's 5 times the width, which is 2, plus length times height. Our length is 5. And our height, we say, let it be what? X. So that's 5 times x plus the width. Our width is 2 times the height. Remember, our height is what? Is x. Just like that. Okay, just for the sake of my brackets, let me just rewrite here with these other ones. All right, so let me just have it this way. So let's simplify and see inside of the brackets here. That is, we are going to have 5 times 2, which is 10, plus 5 times x, which is 5x, plus 2 times x, which is 2x. So adding these, simplifying together, we're going to have the part of the like terms. So you must consider the like terms, 5x plus 2x, which is what? 7x. So that was going to give us 7x. So you can even multiply by 2. That is multiply by 2 into the bracket 2 times 10. That is 20. 2 times 7, which is what? 14. So that's it. We have got this one as the total surface area. So you can just have this in what? Square centimeters. Remember, these centimeters were, the units were in centimeters. So meaning to say area, square centimeters. It is just an expression in x. We must have x on our final answer. Then we are given the B part, item 1, the total surface area that you just calculated before in terms of x. It is numerically equal to 62 square centimeters. Form an equation in x. We formed an equation. It was an expression that we just had for the expression, for the total surface area, this expression. Now the question is, we are supposed to form an equation, meaning to say we must have two equal things to be related, which is what? The total surface area that you calculated before in terms of x. So you take this part as it is in terms of x, as it represents what? The total surface area. So we're going to take that in terms of x, 20 plus 14x. It must be equal to the numerical value that you're given, which is what? 62. That's to form an equation. Form an equation. You end there. The question is not about solving it. Just form, answer the question. You see, the problem of paper one is that it's correct answer only. So you form the equation, you solve, you give the value of x, it's already wrong. Even though the correct answer, we can see it. But where are you going now? But if we check, the item 2 is the one that is now saying solve that equation that you formed in B item 1 to find the value of x. Zviya zvawanga wagadzira pana item 1 chinozvisolva iko zvino kuti utiudze kuti x ndiani. Chirova kuti tanga tamhanya pakusolva pana x kana wanga wasolva. Iko zvino chisolve. Now solve. So you take that equation as it is, you solve. So that is it. 20 to the other side was going to be a negative x. So 14x is equal to 62 minus 20. So to find the value of x, we've got 14x, which is 62 minus 20. That was 42. All right. This one, 42 by 14 by 14. So guys, this division, division, ngadzivewo dzava kugara mind medu. Zvinokwanisika izvi nekugara uchishandisa required instruments anenge achidiwa kana required things zvinenge papepa raunenge kushanda nayo. Paper 1 usashanda necalculator, paper 2 shanda necalculator, zvidzidze uchingodaro. So that is how we learn. So in this case, 9a, we are given a solid object has a mass of 300 kilograms and a volume of 2 cubic meters. Mass and volume. Calculate the density of the object. So the density can be calculated. If you do not understand this, then simply use the MDV triangle. All right, MDV. Okay, this is mass, and we've got density and volume, just like in terms of those, in terms of other triangles that you have, guys, in your mathematics, science, we can use that one. So this one is called MDV. MDV, mass, density, volume, or MDC, where we can see the C for the what? Capacity. C, capacity. So it's volume or capacity there. In place of volume, you can use C there. So what is it that you have to calculate? The density here, the density. So meaning to say, making the density the subject, it follows that density is mass over what? Mass over volume. That's it. What is the mass? In kilograms, 300 kilograms over the density in what? Cubic meters. So it will give us kilograms per that unit that you're dividing. So that's our density. Just like that. So our density was going to be 2 into this one, that's 150 kilograms per what? Per cubic meter. You're done. Then the B part of our question is that a solid object has a mass of 300 and a volume of 2. If you check this information that you're given is the same as what we had here before, where we had a solid object that is a mass of 300 and this, and we calculated the density of that object. we have got the density there, which gives us a relationship between the mass and the volume of the object. Then the question is, calculate the volume of a similar object. Similar object. Given that its mass is 975 kilograms. We have got its mass. What is the density? What is the volume? Okay. So the density gives us a relationship between the mass and the volume. And for these two that are similar, they have same density. Their density is the same. So if the density is the same, it means from the 300 kilogram 2 cubic meter object, the density that I obtained, I'm going to take it as it is. This is my density here. So I have a density of 150 kilograms per watt per cubic meter. What will be the volume given the mass, the density? How can we calculate the volume? We are still back to this. Now, volume will be what? Mass over what? Over density. Just like that. So we can calculate it from there. So volume will be what? Mass over density. So what is the mass? 975 over what? A density of 150. So for the sake of time, guys, I want you to divide this part until you have got 6,5. Okay, so that was going to be your volume of 6,5 cubic meters. Or we can use the similar concept. When two objects are similar, remember your similarity. Similarity. That's another way that we could have answered this question. So for similar figures now, we are already given the volume. So meaning to say we deal with what we call the volumetric or the volume ratio. The mass as they are, these masses, they are part of the volume also. So if they are part of the volumes, we can simply equate them straightforward, guys. 300 kilograms is equivalent, its volume is equivalent to 2 cubic meters. What about that object that has got a mass of 975 kilograms? What will be its corresponding volume? Play around that way. Whether it's going to be less, it's going to be more, whatever that we want on top. 975 over what? Over 300 times 2. So still, you're going to have the same answer. So I want you to simplify that one as an individual. You are going to obtain the same answer of what? 6,5 cubic meters. So I do not know how you answer this question or any other understanding that you have on this question. Let us communicate so that we can see if there are any further adjustments to be done for the next revisions. On question number 10, the diagram is a sketch of the graph y is equal to x squared plus x minus 12. Okay, this is the graph that we are given as a sketch. So we have got the x and our y-axis, that's a 0 there. This is the point K. This is our M, and this is our L, the x-intercepts. The graph of y cuts the y-axis at 0K, this one, the y-axis. The y-axis, that is the y-intercept. So that is our y-intercept. Remember the y-intercept, it's on a condition where x is equal to 0. It crosses the x-axis at L and M. L and M, the x-axis, that is where it crosses. So at point L and point M, it simply means y is equal to 0. Remember, we are in the x-axis, along the x-axis. That's y is equal to 0 there. Okay, anyways, let us go to the questions, guys. This is just about the information. So the first question was write down. I don't even need to calculate. Chingonyora kuti k ndiani. Chingotiudza kuti k, chingotarisa equation wotiudza kuti k ndiani. So k ndiani minus 12. Tinozvoona sei kana x ari 0, the y intercept is what? Minus 12. Anyways, if you cannot see that properly, then substitute. Remember, I said for the y-intercept, x is equal to what? 0. So substitute in place of x. So that's 0 squared plus 0 minus 12. Still, you're going to get the minus 12, just like that. So among my questions are calculate, anongonyorwa answer. Your paper one yacho, okay. So we have got the k value there. That's how we can answer this question. We just have to be very, very careful. Anyways, let's see. So with this, okay, got minus 12 there. Let's see if the next question have got any effect to this one. B, find the length of LM. The length of LM. 3 marks for that. Chatrukuda, a length distance, just like kubva pana L kusvika pana M pakakura zvakadii. How long? Okay. If we are to consider, we do not have the values here. If we had the values there, it was going to be easier for us. We can see that, yes, L is on the negative. Let's say it was something like this. This is -1, -2, and this is 6. And this is our L, and this is our M. What will be the length? Length. Someone can say the length there is 4 in between this. No, it cannot be. The length is the difference between these 2 points. Remember, from -2, there's a distance that is covered to the 0. And there's a distance that is covered from 0 to 6. Pane nzvimbo yatokavwa, pane distance iripo, pane distance mbiri. So for you not to be mistaken there, to say there are 2 units, kubva pana -2 kunobata pana 0, pane 2 units. Or kubva pana 0 kunobata pana 6, pane 6 units. So 2 plus 6, takuwa na 8. I'm not saying this is the answer to our question. I'm saying if you are given something about a horizontal line, you can find the length that way. But take note, if you have got measurements from this to 0, consider that distance yekunosvikao pana 0. So for you not to have any mistake of answering this question, whenever you are to calculate length and it is on a horizontal line, or it is on a straight vertical line, tikangoona iri vertical line, detanga something zvakagara muna y-axis, zviri mu-vertical line, length yezvimwe nezvimwe zverudzi rwakadai unozviwana kubva pa-maximum value minus the minimum value. With this way, you never have a mistake. Chingotsvaka kuti chiri kunzi maximum ndiani. If it is -2 up to 6, maximum is 6 minus minimum wangu ndiani, ndi -2. Zvinondipa exactly the length between the 2 points. Haufuata dambudziko kana pakadai. But like I said, it is only for the horizontal and the vertical lines. If whatever that you're formulating is giving you a vertical line, use this information. If whatever that you're formulating is giving you a horizontal line like this, use this information. Zvikangoendawo nepamwe hazvichashandi. Ngatsvake dzimwe nzira. Okay? So not always where you just have to apply. Ngazvingoshande pese, kwete kwete. So the question is, how to calculate L and M first, so that we can have the length. Ngatitsvake kuti kweye L wacho ndiani, ko M ndiani. What would be these values? How can we solve for these two? Remember, I said in the x-axis, y is equal to 0. So taking this, x squared plus x minus 12, which is exactly equal to y. But this time, we are going to equate that y to 0 in the x-axis. So we can solve for x. Is this a quadratic equation? From your factorization, remember, I said if the coefficient of x squared is 1, say is chingonogadzika x ne x pana. So that x times x is not x squared. Then for these two here, you have to figure it out from what? From the constant. Minus 12. The constant of minus 12, we need the factors there of minus 12. What are the factors of minus 12? Which will add up to positive 1. Manamba maviri ekuti kama multiply anokupa minus 12. Asuka zuma edda anokupa 1. Ukanuma batanidza anokupa positive 1. Manamba maviri. So which two numbers are we referring to? When you multiply, you obtain a negative 12. But when you add, you must have or obtain a positive 1. So it's a trial and error. Try the values negative 12 and 1, 12 and negative 1, negative 6 and 2, 6 and negative 2, minus 4 and 3, 4 and minus 3. Try. Then add. Oeda pamwe ne pamwe uchieda. Not panonokupa 1 in the papi. So you're going to see that the 1 was going to be here. 4 and what? And minus 3. So if we add here 4 plus minus 3, that's a positive 1. So you're going to take the 4 and the minus 3. These are the numbers that we want. So panapatina plus 4, panapatina minus 3. So each bracket, when it is a question like this, you equate each bracket to 0. Remember the 0 product, the 0 concept. So x plus 4 is equal to 0. Meaning to say, if x plus 4 is equal to 0, or x minus 3 is equal to, we're going to have two possible values of x. The minus 4, or the x, which is equal to what? Minus 3. To the other side, that will be positive 3. So which one is minus 3? Which one is minus 4? Ariku negative, from the origin to the negative. That's our L. So L is the one that is our minus 4. And our M is the one that is what? 3, the positive there. But the question is not about determining these x. It's not about x values. It's not about x values. The question was on the length. Pakakura zvakadii kubva pana L kusvika pana M. Length. That is the question. And like I said, if you are working with a horizontal line, simply work with maximum and minimum. So therefore, our length was going to be what? The maximum value, which is the positive 3, minus the minimum value, which is the negative 4. That one is going to give us a positive, that's 7. So meaning to say, we have got 7 units here in between. We have got 7 units. We can figure out from L here to the origin. Minus 4 here. There are 4 units. From the origin to M, we have got 3 units. So 4 plus 3. Chimwe chiri ku negative side, chimwe chiri ku positive side. Ndozvangosiyana chete. One is on the negative side, another one on the positive. So never be tempted there to add minus 4 plus 3. No, not like that. Okay, anyways, let us see the other part of the question. Sake of revision, it was an important question here. We were given that on question number 11, y is directly proportional to the square root of x. Y is directly proportional to the square root there. The square root of x. So we must have the root sign. Okay, so that's the square root of x. On A, we are given that x is equal to 8 when y is equal to 16. Find the formula connecting x and y. The constant is not indicated there. So meaning to say we must get rid of the constant, okay, to have that relationship, this and that, all right? So that's it. So y is equal to, introduce the constant, that's k, the square root of x. So substituting the information that you're given, x is 8 when y is what? 16. So in place of y, you're going to substitute 16 is equal to k, the square root of x, where our x is what? Our x is 8. So it's unfortunate you can't determine the square root of 8, okay? But we can have this one just simplified in set form. Remember, square root of 8, that will be 4 times 2. Or you can have in those 8 what prime factors. I mean, they're just prime factors and so on, the numbers that you use into 8. Not like prime factors, the number that you can just divide without leaving a remainder, that 2, 2, 2, and so on. So until we can have the number that can be written in form of exponents and so on and so on. That one is another way, guys. I explained it. You can work on that one. So the square root of 8 is 2 square root of 2. Or I was saying, let me explain it here and see. 8. So we are going to work with a smaller number here, which is 2. 2 into 8, that'll be 4. Another 2, 2, 2, that's a 1. So as you can see, we are done. So 8 can be written as 2 times 2. And this one, it's a pair. So you write it out of the square root. And this 2, which is not a pair, you write it inside of the square root. We are just like trying to simplify our sets when it is like this. So this is what we are going to have on the square root of what? 8. So 16 is equal to k times 2 square root of 2. The square root of 8 in simplest form. We cannot simplify it, as you can see. So on this question, we must continue. I do not know here there was a vice versa in terms of the values, or it was exactly as it is. If it is exactly as it is, don't be tempted to change those values, because it's exam. Exam, you don't change the values to suit what you want. You work with what you're given. Whether it is a mistake that is there, work with what you're given. What if it is the correct thing? Then you assume that it's a mistake. So divide here, k is equal to what? So you can have this one simplified. You can even reduce this one, guys. 2 into 16, that's what? That's 8. So it was 8 over the square root of 2, but we know our sets. Rationalize what? The denominator times square root of 2, square root of 2. So 8 times square root of 2 is what? 8 square root of 2 over what? Square root of 2 times square root of 2. That's what? That's a 2. Okay, remember square root of a times square root of a is what? It's a. So that's it. 2 into 8, that was going to give us what? 4 square root of 2. So meaning to say, simplifying this part here, whatever that we have, it was going to give us what? 4 square root of 2. So that's our constant, 4 square root of 2 in simplest form. With the constant that we are given, we can have the relationship there, because we are saying y is equal to what? Y is equal to k, where our k is what? 4 square root of 2. So that's 4 square root of 2 times square root of x, all right? Square root of x. So here you can have it like this, or you can have in simplest form, y is equal to, remember, square root and a square root. The 4, you can have it outside, but here you can multiply square root of 2 times square root of x is going to give us square root of 2x. You can combine these two under the square as they are under the square root. It's not a problem. So that was it on this question. Then the B part, find the value of x when y is what? When y is equal to 12. So when y is equal to 12, we are going to substitute here into this relationship or this relationship, guys, depending with which one are you having in simplest form. If you're having that one, that is y is equal to, right, 4. If you're having this one of 4 square root of 2x, still one and the same thing, 4 square root of 2x. Then the question is, find the value of x if y is 12. So we are given the value of what? Of y there, which is 12. So 12 is equal to 4 square root of 2x. Okay, we need to find x, so divide by 4 like this. That will be what? 3. So 3 is equal to the square root of 2x. How can we find x? Simply square. So you're going to square both sides. 3 squared, that's 9, is equal to, remember we squared so that we get rid of what? The square root. So we remain with the 2x. Just like that. So divide by 2, that's our x was going to be what? 2 into 9, that's 4.5 or 4.5. So that was it for the x value. So you see, it simply means the first part as it is. We're just supposed to continue with it. Do not change the question to suit what you want, guys. It's exam. Answer the question. All right, 12 we are given. On A, evaluate item 1 over 3 to the exponent of what? Minus 2. So when I'm given a negative A over B to the exponent of negative n can be rewritten as B over A to the exponent of n. Take note. It was a negative exponent. Now it's positive. It has changed. The change of that positive, of that negative to positive, also affects the fraction. It was A over B. Now it's what? B over A. So you can use this one direct, because there we are given 1 over 3 to the exponent of minus 2. So this is our A over B. What is inside here of the fraction? A over B. So you interchange it. But the moment you interchange this one as 3 over 1, the moment you do this, the exponent changes to a positive. It was a negative, now a positive. That's it. Working with a positive is easier, but just going to square 3 squared. It's what? That's 9. 1 squared, that's 1. Which is what? Which is 9. 9 divided by 1 is what? It's 9. You're done. Or you can go back to the basics of your negative exponent to get rid of a negative exponent. It means 1 over x to the exponent of a negative. It's fine. So meaning to say, if I'm working with this, I can simply rewrite it. I'm no longer using this. It's another way. I get rid of that negative as 1 over what? The fraction as it was 1 over 3 to the exponent of a positive now. That's another way. So meaning to say it will be 1 over what? 1 to the exponent of 2, which is 1 over what? 3 to the exponent of 2, which is 9. 3 times 3. So we have got 1 divided with it, which is the reciprocal of this, if you understand it. But if you don't understand it, simply write it as 1 divided by what? 1 over 9, which is 1 times. You interchange 9 over 1, which you give us for 1 mark. I'm not saying it's wrong. It is fine to do that. But consider time frame also in exam. Like I said before, paper 1. If you know the answer, just write it. 4 squared plus 4 to the power of 0. This is not a product. If it was a product, we were going to use the laws of exponents. For same basis, you're multiplying, you add the exponents. So it was going to give us a 16. But in this case, it is an addition. So we cannot use the product concept. There is no law there for addition. You simplify each on its own. 4 squared, 16 plus 4 to the power of 0, which is what? Which is 1. Any number, when raised to the power of 0 is what? It's 1. So you can add 16 plus 1, which is 17. So ndo chinonzi zama unogara pasi, so understand chi chandakapiwa ndoshanda nacho sei. Okay, then yeah, that was it. So then the other part, it was factorization. I think there's a part that I just left. Let me check down. There's another one. Oh, here. So if we check here, solve the equation. 5 to the exponent of a minus 1. 5 to the power of what? A minus 1 is equal to 125. From our number, from our exponents, we are dealing with indices, same bases. So 125 anganyoreka here mubase ra5. Zvechokwadi anokwanisa kunyoreka base ma5. It can be written in the base of 5 as 5 to the power of what? 3. Where we do understand that if the bases are the same, exponents will be exactly the same. So here we're just going to equate. So that is a minus 1 is equal to what? 3. So if a minus 1 is equal to 3, solve for a. We now have a new equation on its own, a new statement. From that statement, we formulated a new statement where we can solve. It's a linear equation. So take the minus 1 to the other side. That was a plus. So a is equal to what? 3 plus 1, which is 4. Just like that. Just like that. Considering the other part of number 13, we are given factorize completely on a. Factorize completely 5m squared minus 20. Remember the golden rule of our factorization. You must consider the highest common factor first. Between the two terms, are we having the highest common factor? That's our golden rule. Between 5m squared and this 20. Anything common? Yes, we can see that 5 is common there. So we can factor out the 5. So 5 divided by 5, that will be m squared. It's like this, 5m squared over 5. So it will cancel. Okay. So these two will cancel, 5 and 5. So you've got what? M squared that is remaining. Then you do the same thing for the negative 20. Negative 20 divided by 5, that was negative 4. But the question is, factorize completely, factorize fully. It's not about putting in brackets as most of us assume factorization is. Akangoona ma brackets chete zvatonaka. Wait. Is it in its simplest form? What does it mean? Is it completely factorized? What does it mean? If there is any factorization to be done, continue up to the state that you cannot factor anything. Kusvika pekuti factorization hakuna zvochaita. So here, it's not about the terms that are the same or that are common, but it's what? A difference of two squares. M squared is a perfect square. 4 is a perfect square. It can be written as m squared minus this 4 can be written as 2 squared. Remember the factorization of a squared minus b squared. It gives us what? A minus b into a plus b. Zvakareizwa to the power of 2 izvo ndozvatiri kuda. Saka chireva kuti tirongonotora, that's 5 into what? M and what? The 2. So that's m minus 2. Another bracket, m plus 2. Or simply the square root of m squared, which is m, the square root of 4. So one bracket subtracts those roots. Another one, it adds. Or one adds, another one subtracts. The order does not matter. Okay, 13b, simplify this. Given a fraction, what is it that is important here? Factorization. X, 3 is common on top, so you can factor out 3. That was going to be x plus y. Are we seeing the difference of two squares? If we solve the a squared minus b squared, definitely you must see this one, x minus y into what? X plus y. Just like that. So this was going to cancel. We have got 3 over x minus y. We are done. There's nothing that we can do from there. Then considering the B part, the table below shows the number of children living in houses at the staff quarters at a certain school. Find the mod. So the mod is the number with highest frequency. Where are we having the highest frequency? So this will be our frequency, like the number of houses corresponding. So 5 corresponding what? The number of children in a house, which is what? Which is 3. So 3 is our mod, number of children in a house, because of that corresponding frequency value. Then we move on to the median. Remember the median from half of the distribution, half of what? N plus 1 distribution. If you're given this form, if you are working with half of n, but it's half of what? The distribution that you're given. So the distribution, this is the position. We are finding the position, then we will find the value. So our distribution is the frequency, the total frequency, 2 plus 3 plus 4 plus 5 plus 1. This is our frequency corresponding. That was, we're going to have a frequency of what? 7, 15. 5, 5, 10. This 2 is 10 plus this one 4 plus this one 15. So that's our frequency. So half of what? So we need like half of 15 plus 1, which is, this is 16. Half of 16, which is the 8th position. The 8th position is where our median is found. The 8th position. So if we are to count these numbers, the 8th position, 2 plus 3, that is what? 5. Then 5 plus 4, as we can see, it is 9. 5 plus 4 is 9. Meaning to say the 8th position occurs here. The 8th position. We are already at 9. We have already passed the 8th position. You can do it even from this side. 0 plus 1, that's 1. 1 plus 5, we are now this one. 1 plus 5 is now 6. So if we take this 6 plus 4, it's now at 10. 10 has passed what? 8. So meaning to say 8 occurs here at what? At 4. At 2, I mean. So that is our median value. So in this case, therefore, our median value will be what? Will be 2. You now have the median. Then the mean, remember average, guys. If you're given this form of a table, you just multiply the corresponding values, then divide by the frequency. So I want you to multiply this 0 by 2, 1 by 3, 2 by 4, 3 by 5, 4 by 1, 5 by 0. So I want you to multiply those. That will be the numbers you obtain on top, which is 30 over, remember I said the frequency is 15. So that was going to give us a 2 again. So here, guys, we multiply as it is. This 1 times this plus 0 times 2 plus. Guys, you cannot just multiply. Just see 0 times 0 plus 3 plus 4 times. Some of these values, you can even see them direct. It's not always where you must multiply this one times this one. It's not always. Sometimes you can just consider to say, all right, I have direct values. Let me just use direct values, all right? Then from this diagram, we are given on number 15, they are saying it's a triangle there. RST. Okay, we've got our R there and our S and T. MN is parallel to ST. Then there's line M here and N, so that these two, they are what? Parallel. And we're given these dimensions. This is 5, this is 8, and this MS is what? Is 10. From that given information, the question on A was to name the triangle similar to triangle RST. Which triangle is similar to triangle RST? That is the question. So to find the similar triangle, we must work with the angles which are exactly the same. Remember, similar figures, I say they are equiangular. They are equiangular, meaning to say we must find angle equal to R. R is this one here, and it is the main angle of the triangle, so it remains as it is. So that's similar to triangle R. Then S, if we check where S is, this is our angle S. It is exactly the same as angle M from what? Corresponding angles, remember? Where we've got parallel lines and we form an F. We talked about the F before. These angles that form F, it can be an F like this. They are called what? Corresponding. So S is the same as what? As M. What about T? This one. T is same as what? As N. We're done. Corresponding angles as well. As you can see, it's an F which is facing this side. That's how we name similar figures. Equiangular from the angles which are exactly the same. Then from there, find the length of NT. Find the length of what? NT. So NT is this section here. That is where we've got our NT. So we do understand if we've got similar figures, the ratio of their sides is the same. So we are going to think about that. Since we've got similar figures, let's work with what? Ratio of sides. Let's see. RS over what? RM must be equal to ST over what? MN. This is what you're going to think, which is equal to RT over what? RN. That's ratio of what? The ratio of sides is exactly the same throughout. But on this ratio of sides, are we having NT? Because the question needs us to determine the length of NT. There is no NT here. There's no NT. We have ST, and this is where T is. And this ST has nothing to do with NT. So let's ignore that one. There is RT from R to T. From R to T, we can see that NT is there. It is included in this line. Mm-hmm. There we have NT. Let's check properly our line. Check properly your line. If you are to consider from R there to T, NT is in RT. So by finding RT, we are finding NT by disguise, in disguise. So meaning to say, let's focus on finding of the RT. This one is no longer important. It's no longer important. So we focus on determining what? RT. So meaning to say, we're going to equate this one to this one. We find what? We find RT first. So find RT first. So RS, what is the ratio? What is the value from R to S? The whole of this from R to S, 5 plus 10, which is what? 15. Over RM from R to M, that is what? 5. So 15 over 5 is equal to, remember, equal to the last one of RT. So that's RT over what? Rn from R to N. This one from R to N, it's what? It's 8. If you wanted in RT, you are simply going to write it as 8 plus NT in this equation here. You're going to just have it there in place of what? RT. you're just going to write as 8 plus nt if you want it like that. You form your equation with nt as it is. It's not a problem. Or you can simply find RT, then you find nt from there. There are two ways. Okay, so to find RT, simply multiply by 8 to get rid of this 8 here in the denominator. So meaning to say our RT is equal to what? So if you were to multiply this side, this is just a 3 times 8, which is what? Which is 24 centimeters. So meaning to say, if from R to T is 24, from R there up to T, the whole of this line, if it is 24, and from R to N is 8, what about from N to T? It will be just a difference there. So therefore, NT is equal to 24 minus what? 8, which was going to give us what? 16 centimeters. That's it. Or you could have just calculated it straight from that consideration that I was explaining, that in place of RT, you can write your RT as what? Okay, in place of this RT, we can rewrite that RT as what? 8 plus NT, like this. So if RT is 8 plus NT, another way was going to be easier. We're just going to substitute. Remember the first part, you substitute in your ratio. 15 over 8 is equal to, in place of that RT, you are no longer writing as RT, you are writing now with that NT that you want to calculate. So it's 8 plus NT. Everything over what? Remember, it was over 8. So that's it. We have got an equation to solve again, just like the previous case. Okay, let's see what's happening here. Times 8 times 8. This was going to cancel. So that's 8. So 15 is equal to 8 plus NT. To the other side, that's 15 minus 8. Okay, which is equal to NT. Was this 15? All right. So that will be NT. All of this one. Where am I getting the 15, guys? 8 plus NT, 8 plus NT. All right, here I got what? 16. But this one is not going to give us one and the same thing here. 24. All right, let's just see what happened here. 8. Okay, where's this one? Because this one is supposed to just be one and the same thing here. This is 15 over. All right, this is 3. Where am I getting the 8? Oh, because of the way I canceled there. I'm now taking like, it's an 8, this one. It's a 3, this one. Yes, it's a 5 actually there. Okay, no problem. So here it's a 5, this one. So remember on this part, I was now like, where is this value now from? So meaning to say, with that, it was simply going to be the same times 8 times 8. Let's get rid of this one here. So this one, it will be what? 3. 15 and 5, which is 3, then times 8, which was 24, is equal to 8 plus NT. So as you can see, we are back to that one again. 24 minus what? Minus 8. So that's how it can be like under an exam condition. So it means our NT was still going to give us what? The 16 centimeters, just like the previous case. There are so many ways. As long you understand how you are playing around with the values that you are given, the information that you are given on that section of your question. But that was it on the length. That was it on the length. I just want to focus on this one, then we'll see. I don't know if you're going to be able to finish up everything, but let's see. Then the 16, given that the vector AB is given by this, BC is also given, express AC as a column vector. Already those displacement vectors are given, just combine from A to C. It is just like this, guys. We are given something like, it's just like a triangle. This is A, this is B, this is C, where we are given the vector of AB and the vector of BC. And you want to calculate the vector of what? AC. So from A to C, that's AB plus BC, just like that. So that was the question there. AB plus what? Plus BC. As a column vector, you can add them. It's not about your given vector A, this is vector B. No, they can give you as column vectors as well. So AB is what? 3 minus 4 plus vector BC, which is 6, 4. So you can add corresponding terms, 3 and what? 3 and 6 together. That is 9 minus 4 and a 4. That was going to give us a 0 if we add minus 4 plus a 4. Simply 4 minus what? 4 minus 4. So that was the vector AC as a column vector. Then the B part was to find the modulus of what? AB. The modulus, the magnitude of what? AB. So we have got vector AB already. So you just need the magnitude. Remember, magnitude simply represents what? The length. So from that AB, this is our X value, this is our Y value. So remember that the magnitude of a vector can be obtained from the square root of what? X squared plus Y squared. Where from AB, our X is 3, our Y is what? Minus 4. So that's 3 squared plus minus 4 squared. So that's it. 3 squared, 3 times 3, which is 9, minus 4 squared, minus 4 times minus 4, which is 16. So adding these two, it was going to be 25, and the square root of 25 is equal to what? To 5. Remember, we are dealing with the magnitude, the length. We cannot say our length is plus or minus. We just write our length as a what? As a positive, magnitude as a positive value. Then 17a, convert this number to a number in base 5. So remember, guys, to base 5, you must convert to base 10. There are so many ways, actually, of doing that, guys. There are so many shortcuts, this and that. But as for me, I want you to know the proper way. Convert from one base to one base. Definitely, you must go via what? Via base 10. Let's go via base 10. So it's easier for you to convert to base 10, raised to the powers. 2 to the power of what? 0, 2 to the power of 1, 2, 3, 4, and 5. So you're going to multiply these corresponding to each. So that's 1 times 2 to the exponent of what? Of 5 plus 1 times 2 to the exponent of 4. There is a 0 there. So definitely whatever that you're going to have, there is what? It's a 0. So you can even ignore that part. We move on to this one, following one. All right. Okay. All right. This one, just hope it's not gonna take out my board. Let me just open this one. All right. It happened. So I'm just gonna come back, guys, with the second section. As you can see, it needs us to go back to the board again. It happens. See, this software is right. It was surprised. Why am I working with a lot of things? But let's see in our next part. I'm just gonna combine it now. All right, so on this case, I'm just gonna rewrite this one aside and see. Okay, let's see it. So remember, this was our number. So we are going to have it, like I said, to the base of 10. Then we try to convert it back to base 5. So to the base of 10, raise these to the base that you're given, the powers of the base that you're given, which is the base of 2, to the power of 0, to the power of 1, 2, this is 3, this is 4, and this is going to be what? 5. So that was going to give us 1 times 2 to the exponent of 5 as we had before. So like I say, that's a 0 there. Then we've got 1 times 2 to the power of 2. That's a 0 there. So we are simply going to ignore it and move on to 1 times 2 to the power of 0 there. 2 to the power of 5, that's 32. We multiply it to 1, so that's 32 plus 16 times 1, which is 16. That's a 0 there. 4 times 1, which is 4. That's a 0 here. 2 to the power of 0, that's 1 times 1, which is 1. So we're going to add everything. So that's a 20 plus 32, which is 52, plus 1, which is what? 53, which is in the base of what? In the base of 10. So you can write base 10, or you can just leave it like that in the base of 10. But do not forget, as of our question, it was to convert to the base of what? Of 5. So it is easier a number which is in base of 10 to be converted to any base. You just need to divide by that base throughout, noting out the remainders. So that's 5 into 53, noting the remainders down. So 5 into 53, that's into 50, which is 10 times. Then we've got a remainder of 3. 5 into 10, that's 2. We do not have a remainder. 5 into 2, that's a remainder. That's a 0 there, and we've got a remainder of 2. So taking the remainders as our answers from the bottom going up, our answer was going to be 2, 0, 3 in the base of 5. So that is how we can play around our number bases. So like I said, we are going to try by all means, for those who are going to sit for November, to have introductions of topics covered each section. It's unfortunate that some of the videos that we used to have are no longer available. So we have to work on those introductions. So especially for paper 2, paper 1, know your basics, guys. Know your basics. Arrange the following numbers in ascending order. Ascending order, as we do understand, increase 1, 2, 3, 4, 5, and so on. So these numbers that we are given, they are just given randomly. And we can see different bases there. So how can we compare these numbers? It is best for us to compare if they are in base of 10. It is a base that we understand. Base of 10, these are numbers 1, 2, 3. You can see, all right, 4 is less than 5. It's easier for us to compare numbers in base 10. So meaning to say that 13 already in base 10, we're going to leave it like that. Just 13, just any other number. So we're going to convert these to 1, 1, 0, 1, base 2 to a base 10 so that we can easily compare. So remember, to the power of 0, 1, 2, 3, and 4. So it was going to be 1 times 2 to the power of 4. Move on to this one, plus 1 times 2 to the power of 3. That's a 0 that we are given. So they're going to just leave it. All right. Then we've got 1 plus 2 to the power of 1. We have got a 0 there. So just leave it again. Okay. Just ignore it. 2 to the power of 4, 16 times 1, which is 16, plus to the power of 3, that's 8 times 1, which is 8. All right. Then 2 here. So 10 plus 16, that was going to give us 26. 10 plus 16, which is 26 in the base of 10. So we have got 26 representing what? The number that we had in the base of 2. Here we're just writing in the base of 10 for the comparison purposes, for comparing our answers at the end of the day. We need to compare these values. It is easier in the same base So we do the same thing for 3, 1, 2 in the base of 5 to the base of 10. So that's 5 to the power of 0 there, to the power of 1, to the power of 2. So 3 times 5 to the power of 2 plus we have got 1 times 5. So this is 1 times 5 to the power of 1 plus the 2 times 5 to the power of 0. All right, so let's see. 5 to the power of 2, that's 25, times 3, which is 75. So we've got 75 plus, this is 5 times 1, which is 5. This is 1, and 1 times 2, which is 2. So if we add, that's 80 plus 2, which is 82 in the base of 10. So we have got 82 in base of 10, representing what? The 3, 1, 2 in the base of 5. As we have these numbers in base of 10, we can see which one is the smallest up to the biggest value in ascending or from the smallest value. So we have got 13 compared to 26 and 82. We can see that 13, that's the smallest value. So it was going to be 13 in base of 10 as it is on the question. Okay, then followed by 26, all right, base 10, but 26 base 10 was from what? From this value, right? The answer, the way that it is given on the question. So that was 1, 1, 0, 1, 0 in the base of 2, followed by what? The 82 base 10, which is equivalent to what? To 3, 1, 2 in the base of 5. So as we can see, having the numbers in base of 10, it is easier for us to compare to say this one is followed by this, followed by this. Given the two numbers on question number C, we are given now to evaluate these two numbers in the base of 5. As they are in the base of 5, simply subtract 3, 1, 2 in the base of 5 minus 1, 4, 3 in the base of 5. So this was a straightforward question. 2 minus 3, that's impossible. So you add the base on these two. We're going to add 5, that's 7. We give 1 on our 4, so it was going to be 5. So that's 7 minus 3, which is 4 in the base of 5. 1 minus 5, that's impossible. So we add the base. 5 plus 1, that's 6. We give a 1 on 2, so that's, we give a 1 on this one, so it's a 2 now. Then we're going to subtract 6 minus 5, that's 1. 3 minus 2, which is 1. So that was 1, 1, 4 in the base of 5. It's already in the base of 5. Then on number 18, the scale that we are given on a map, right? The map that we have, it has a scale. And that map, that scale that we are given is in this form. This format, what does it actually represent? Because the question further on is about finding of the distance on the ground represented by 1 centimeter on the map. Give the answer in what? Kilometers. So if you have the understanding of the given scale here, it was going to be easier for us to answer this question, because from that understanding, it tells us that a unit of what we can see on the map is equivalent to 150,000 units of what we see on the ground, which is the actual ground. So that unit, you take it as a centimeter. 1 centimeter on the map as to what? 150,000 centimeters also on the ground. So it is a relationship of what is happening on the map, on the paper, to what you see exactly on the actual ground. So these are centimeters, guys. These are units which are in your hands, which can be converted to any unit. In a meter, we have got what? 100 centimeters. In a kilometer, we have got what? 100,000 centimeters in a kilometer. So we can change these centimeters to the kilometers as we need our answer in what? Kilometers. So simply divide by what? 100,000. So dividing by 100,000, that was going to give us what? 1,5. So that's it. In kilometers. So we are simply saying the 1 centimeter that we were seeing on the map, it is still the 1 centimeter that we are seeing right now. The 150,000 centimeters, it is still the same as this one on the ground, 1,5. Only that we are rewriting in another unit, but these two are exactly the same. So this is 1 centimeter on the map, 1,5 kilometers where on the ground. So this is what they want. The distance represented by 1 centimeter on the map. We are on the map. What is on the ground is what? 1,5. So the answer there was simply 1,5 kilometers. So like I said, if you had an understanding of the scale, it was very much easier to answer this part. So you just need to work out more questions. On the other part of the question, which is B, the distance on the map representing a distance on the ground of 7,5 kilometers in centimeters. So remember already, guys, we have got a relationship, which is just like a scale that we can consider to what is on the map to what is on the ground in kilometers. Remember, this is what we got from the first item. So it's just a continuation. What is on the map? What is on the ground? So it corresponds. You are given what is on the ground here, 7,5 kilometers. So find what is corresponding on the what? On the map in centimeters. So it's a proportion. So 7,5 over what? Over 1,5. So that's 7,5 over 1,5 times what? Times 1 centimeter. So that was the idea of the question with this. That was same as 75 over 1,5 if you multiply by what? By 10. By 10, we've got 75 over what? 15. So that's the idea. And 15 into 75, that's what? 5 times. So it is going to give us 5 there. In what? Centimeters. So this is what 7,5 kilometers on the ground is representing on the map. On the map, it is what? 5 centimeters. Then on the C part, the actual area represented by an area of 4 square centimeters on the map. On the map, we can see an area of. So take note, the previous condition was a centimeter on the map equivalent to 1,5 kilometers on the ground. This one, we used it to determine, if you check, we used it to determine the distance, because distance, it's just like, it's a linear value. So when you deal with the linear values, you deal with the linear scale factors, just like you are dealing with the scale factor of a linear. But when you deal with the area, as you can see here now, they talk about area from this scale factor, which is your linear scale factor, you must determine the area factor. Okay, you must determine the area factor. How do we determine the area factor? By squaring our linear factor so that we've got the square units. First, you deal with what represents a square centimeter on the map. So 1 squared, that's 1 square centimeter, as to 1,5 squared. So 1,5 squared means what? 1,5 times 1,5. So I want you to multiply that, guys. You're going to obtain 2,25. All right. 15 squared is 200 and what? 25. Then 2 decimal places. So it's 2,25. 2.25 square kilometers. Remember, we are squaring, so it's square kilometers now. So this condition simply means what I see on the map in terms of the area. Remember, this side is what? The map. This is the ground. On the map, in terms of area, I see a square centimeter. A square centimeter is equivalent to 2.25 square kilometers on the ground. A map, ground. So the question is, if I have an area of 4 square centimeters, where on the map? Where is it? It is on the map. So the map, remember, this is the side, this is the ground. So on the map, I have got 4 square centimeters. What is going to be my corresponding area in square kilometers from where? The ground now. What would be that one? We're talking about the actual area. This is the ground. So as you can see, it's going to be more. So that's 4 over 1 times what? Times 2.25. So that was going to give us the area. 4 times 5, that's 20. 4 times 2, that's 8. Plus this 2, which is a 10. Then 4 times 2, which is 8. 8 plus 1, which is what? Which is 9. 2 decimal places. So that's 1, 2, which was going to be what? 9,00. So that's 9 square kilometers. The zeros after the comma are not important. Just like that. So questions can be of this nature. You just have to play around the question. It is given on question number 19. We are given that A is equal to this part, then express M in terms of H and A. They are simply saying, make M the subject of the formula. Make M the subject. So this is what we are given. There are so many ways that we can answer this question. To make M the subject, we can multiply by H throughout. A is equal to 4M times H. That will be 4MH. H times H, that will be H squared. So as we can see, the part that has got M is here, only have M here. So we are going to take the H squared to the other side of the equation. So it's going to be a negative there. A minus H squared is equal to what? 4MH. So to have M as the subject, divide by 4 and what? And H. So this side, 4H. The 4 and 4 cancels, the H and H cancels. So therefore, M is equal to what? A minus H squared over 4H. So that's how we could have attempted this question, of which there are so many ways. So many ways of answering change of subject. You could have taken this way. Since A is equal to H into 4M plus H, and you want to make M the subject, and you can see that M is here. It's not like this H here is having M. It's not part of M. It's not part of M. If we had the M outside of the bracket, then we could have forced it to expand like this. But if we are not having that term here outside of the bracket as M, you can easily divide by that term. So divide by H, since it's a product here, we have got a product, so you can divide by H both sides. So this was going to cancel, meaning to say A over H is equal to what? We are going to remain this side with what? 4M plus H. Remember, we are focused on M. So you can take this H to the other side. It will be a negative. A over H. This H to this side, it will be what? Minus. So that's minus H, which is equal to 4M. In order for you to determine or to have the M as the subject, what are you going to do? Divide by 4. So you're going to divide by 4 here. You divide this term by 4 as it is like this. You divide it by 4. this one by 4. So this was going to cancel. So therefore, m is equal to what? So I want you to be careful now on this side. If we are given a over b like this as a fraction, then divided to c, it simply means you multiply the denominators together. So this can be rewritten as a over bc. You can multiply the denominators together. So we have got a over h. So meaning to say, using this concept, you are simply going to multiply h and what? And 4. So that is going to give us a over 4h. We cannot have a fraction over another term, no. So combine the denominators. So that's a over what? 4h. So this is what you're going to have, minus what? On this part, we are going to remain with h over 4 as it is. That's it. So these two, this part here and this part that we are having here, are exactly the same. Despite the way that we are looking into the question, these two are exactly the same in terms of the presentation of our answers. If we are to substitute their corresponding values, you are going to obtain same answers there. That is to show that you are working with the same expression for m. So you can even prove that one by this part, where we are given now to calculate m, the value of m, given that a is 20 and h is 2. If you are to substitute these values here, if you are to substitute in this one, you must obtain what? Same answers. So as for me, I'm just going to work with one. You prove with another one. So from the first one, we said m is equal to a minus h squared over 4h. So we are given our a as what? As 20 minus h squared. Our h is 2, so that's 2 squared over 4 times h, which is 2. So m is equal to 20 minus 2 squared. 2 times 2, that's 4 over 4 times 2, which is 8. So subtracting this part of the numerator, that was going to be 16 over 8, which is what? Which is 2. So that's the value of m that you're going to have. So like I said, you can verify with other part, you see that you're going to have the same answers there. The diagram that we are given here, it shows the points A, B, C, as we have got on the circumference of a circle. Then we are also given the line BS, B to S, a tangent. DC produced meet the tangent from BS. Okay, from BS, so DC, all right? DC meets the tangent, okay, here, okay, at S, okay? Then 42 degrees for what? DAC, DAC. So this angle is what? 42 degrees there. So with this information, the question was further, find OBC, angle OBC. Okay, let's see. From point O to B to C, all right, this angle here. So that's our angle OBC. So there we can simply use, guys, the angles that are being subtended by what? The same chord or the same arc, if you're using the arc. If we check chord DC, it creates an angle there at A. The same chord DC creates an angle at B. They are created by the same chord or the same arc, this one. So meaning to say the angle B is also what? 42 degrees. Angles in the same segment, or angles that are subtended by what? By the same chord. That was the condition that we're going to use. All right, then okay, so that's it. Let's check another part, which is CAB. CAB, from C to A to B. All right, that is this one, CAB, this angle. So if we consider angle CAB, which concept that we can use, guys, to determine angle CAB? All right, let us try to figure out in the triangle that we are given. Remember that we have got this chord, this diameter here. It's a special chord, that diameter. And what a diameter does, it subtends an angle of what? 90 degrees at the circumference. Meaning to say the whole of A is 90. Also, this one is 90 degrees at C. The whole of this angle here is 90. The whole of angle A is 90. So meaning to say CAB was simply going to be what? CAB was simply going to be 90 minus 42 degrees, as these angles, they are supposed to add up to what? To 90 degrees. So 0 minus this, that's 8. Even 1 here. So that's 9 minus what? 5, which is what? 48. So it was going to give us 48 degrees. So this is 48. Okay, so that one also is going to affect this angle at D. It is also going to be 48 degrees, as we have got angles subtended by the same chord. And also this angle here is going to be 48. The CBS, as we have got angle between a tangent and a chord. So the chord subtends 48 here, or also that one. So that's another 48 degrees here. All right, so many. Let's see. Okay, so we have got our CAB, 48 degrees, then DSB from D, all right, to S, then back to B. All right, so this one is a triangle, guys. We have got a triangle, and it's actually a right angle triangle because here it's 90 degrees. So to find the angle that is at S here, simply 90 minus 48. And 90 minus 48 is what? 42 degrees. Or you can simply work with angles. In a triangle, you subtract 48 degrees plus this 42 plus the 48 degrees at B. Remember, I said that one is 48. So that one was still going to give us what? 42 degrees. Okay, just like that. So that was the condition. On number 21, the diagram shows 3 towns PQR on a level ground. Okay, then R is equidistant from P and Q. From P and what? From P and Q. Remember, if we talk about the locus of points equidistant from P and Q, that's a line bisector. So R here, they are simply saying it bisects the line what? The line PQ. This line is gonna bisect line PQ. So if this line bisects line PQ, it means this line, it is bisecting R where it is. The angle R is being bisected. So anyways, we are also given this condition of the line that are also the same from P to R and also R to Q. So it means the base angles are actually the same. This side is and this side. So this angle is also 68 degrees. So meaning to say, okay, no problem. Let's say the bearing of R from P is 125. R from P, we are given this one, then this angle of 68. So that was our information. And from that, we are given to find the angle PRQ from P to R to Q, this whole angle, this one. So this was a direct question, guys. As we can see, since these two angles are exactly the same, simply gonna subtract from what? From 180 degrees angles inside of what? A triangle, they add up to 180. So remove the 68 and the 68 as they are exactly the same. That was going to be 136. The sum of these two is 136 from 180, which is going to give us 44. So that is the idea there. So we've got 44 degrees, guys, just for the sake of time. Then the bearing of P from R. All right. So since we've got 44 here, what will be the bearing of what? P from R. Okay, let's see the bearing part. This is where we have got our P and R here. From, we must consider from where? From R then. Remember our bearing, if you consider three-figure bearing from the North Pole in a clockwise direction until we reach this line, which is going to what? To P, this one. So as you can see, the whole of this angle can be found if we have got this remaining angle, this one. And this remaining angle can be determined. Remember, we've got a North Pole and North Pole, this one, they are parallel. So from 125, we can have this angle called interior angles. These angles which form what? A C or a U, called interior angles, they add up to 180. So 180 minus 125 was going to give us 55. So that's 55 degrees. So this angle was going to be 55 degrees. The remaining angle, this one, that we do not need. As we need this one from the North Pole up to this one, it is the one that we need. So what are we going to do? We are simply going to remove that part that we do not need, the 55, from what? From 360. So therefore, our bearing was going to be 360 minus 55, which is 305 degrees. So that's our bearing. So three-figure bearing there, I'm considering three-figure bearing, guys. You can use any one compass bearing. It's up to you. Then see the bearing of P from Q. P from Q. This is our Q. So we do the same thing. We put a North Pole at what? At the Q. So let's see what was going to happen here. If we put a North Pole at Q like this, all right, the bearing was going to be, remember, three-figure bearing from the North Pole of Q. So we're going to have the North Pole of Q here to the line which goes to what? To P. So this is the only angle that we need, this small angle here between the North Pole. Remember, these North Poles are parallel lines. So it was easier if we do know this angle here inside of P, this one, the remaining angle, this one. But we can have it from where? 360 degrees. 360 minus these two angles, 125 and what? 125 and 68. A complete revolution. We have that angle of P that is remaining. So that was the idea. So that it was going to give us 360 minus, this part was going to be 167. So if this angle is 167, and we do understand that part of our co-interior angles, remember these lines, guys, they are what? Parallel. So we've got co-interior, this angle of 167, and this small angle that we are seeing here, they are supposed to add up to 180. So we have our bearing. They're supposed to add up to 180. So it's 180 minus 167. So that was going to give us what? 13 degrees. But remember, three-figure bearing, you just have to add the 0 there. So that was 0.13 degrees. Just like that. I think this one was direct. Then considering 22, we are given, in this case, given 4P minus this 2 of this. All right, that's a matrix. Okay, find matrix P in the form. So there's a format. You can even put that format and play around with it. Or you can just know from this format, it's a what? It's a 2 by 2 matrix. That's what they are simply saying. So how can we find P? For P, take this P to the other side. That will be what? Minus P is equal to, you take this one to the other side. So it was a negative here. So it will be positive 2. So this is negative 60 like this. So we can simplify 4P minus P, that's 3. So this was going to give us 3P, then multiply by 2. That's 6 here. This was going to be 3, negative 12. 3 times, that's a 2 there. So if you multiply by 2, that's negative 12. And that's a 0 there. All right. So 3p, remember p is a matrix. So we're supposed to divide by 3 like this. But as of a matrix, we cannot perform this as a division this side. But rather we express it as 1 over 3, just like the inverse. So it will be 1 over 3 like this. So that here you are dividing as, but on this side, you write it as 1 over 3. Guys, even if you put that in mind and divide in mind, as long as you are the one who is understanding what you're doing, to say 3 is going to divide everything, it's not bad. But the proper presentation is this. So a third of 6, simply the same as 6 divided by what? By 3, which is 2. A third of 3 is simply 3 divided by 3, which is 1. A third of minus 12 divided by 3, which is minus 4, the same. That one was going to give us what? A 0. So this is our matrix P. As they said, from the presentation A, B, C, D, it's a 2 by 2 matrix. And this is what we can see. And the other question was now to find the inverse of P. We have that matrix. Let's find the inverse. From what? The determinant first. Then we understand the inverse can be found. So let's find first the determinant of P from the product of the major diagonal, which is 2 times 0, minus the product of the minor diagonal, which is what? 1 times minus 4. So that was going to give us 0 minus 1 times minus 4. That's minus 4. Then minus and minus, you add. That will be what? A positive 4. So therefore, the inverse P to the power of minus 1, that's the inverse of what? Of the matrix P. So the inverse of P was going to be 1 over the determinant. Then what happens in our matrix? Those numbers in the major diagonals, you exchange them, you swap them in the major diagonal. So that will be 0, 2. What about the minor diagonal? The minor, you multiply by a negative. So on this one, multiply by a negative. On this one, multiply by a negative. So it was going to be negative 1, negative times negative 4, that's a positive 4. So that's our inverse. We are done. From what you calculated, it's a continuation. So you see, if the first part is wrong, it means that was going to affect the second part. On 23, we are given sets. Okay, this is the Venn diagram. This Venn diagram shared A intersection B. This is a combined part. But after that, union C, combine it to C. So A intersection B, okay, this is our A, this is our B. The intersection of A and B is this part. That is the intersection of A and what? And B. But we are supposed to combine it with what? Union C. Combine, this is our set C. This is our set C. So at the end, if we combine, what are we going to have? We are going to have the whole of this region that we shaded. That is it. It was just a combine. The intersection, you combine it to the what? To the union. Union means combine everything. That is the whole idea of this part. So we are done there. On B, in a class of 45, we are given 30, they do agriculture. These ones, they do this. So it is the same thing, just like the previous case. But as you can see, we are dealing with 2 subsets for agriculture and for computers. So they are just 2 subsets that you are dealing with. So we are being asked to determine those, find the number of who do agriculture only. So in this case, we need to find first those who do both agriculture and computers. We are given those who do not. 7, they do neither. They are not part of agriculture, no computers. So what about those ones who are both agriculture and computers? Let us know these ones. So we can say, let these ones which represent both be what? Be X. So we must have an intersection for those who are part of agriculture, then the computers. There are those ones X who take both. We indicate them on the intersection. So that if we go back to the 30 who do agriculture, who are part of this whole set, if they are 30, what about those ones who do agriculture only? That will be 30 minus X. It showed there's an intersection, that statement alone. If it wasn't like this, we're just going to take that 30 as it is. No, this is for the whole set of agriculture. Same as the computers. 25, they do computers. It's not only, it's the whole set of C, this one, including X. So what about computers, only this part? It will be 25 minus X. 25 minus X. And 7, they do neither. They are not part of agriculture. They are not part of computers. They do nothing. These are the 7 which are outside. So we have got our universal set. Then the question was, find the number of children who do agriculture only. Find this section, agriculture only. This is the section, which is the 30 minus X. So we must have the value of X first in order for us to determine that section. So find X first. From where? We must form an equation. Remember, I told all these children, there are 46. That's 45, sorry, the universal set. 45 of them. So by forming an equation, we can solve for X. From the sum of every subsection that we see on our diagram, the 30 minus X as it is, if we add it to this X and add this one to the 25 minus X, add also the 7 that we see outside here, we must obtain everything that we are given, which is what? 45. We have formed an equation where we can solve for X, not because we are asked about X, but we know where that X is needed. So let us add 30 plus 25 plus 7. That was going to give us 62. And minus X plus X cancels. We've got minus X that is remaining, which is equal to 45. So to solve for X, we can take the 62 to the other side. That was going to be what? Negative. Minus X is equal to 45 minus 62, which is what? Minus 17. So divide by -1 by -1. Our X was going to be what? Positive 17. So if X is 17 here, if X is 17, those who take both agriculture and computers, if they are 17, what about agriculture only? Simply subtract 13 minus 17, the X that you obtained. So that was going to give us what? 13. So these are the ones who are part of what? Agriculture only. They're just 18. So the finding of X was just helping us to determine that. Otherwise, they're 13. Okay. So moving on to 24, we are given the diagram is a speed time graph of a moving object. The starting speed is 50. All right. Then as you can see, there's a decrease, a deceleration. So it decelerates at 4 meters per square second, deceleration per square second for the first 5 seconds, as we can see. Then it maintains constant speed for the next 20 seconds, from 5 to 25. The difference there is what? 20 seconds. Calculate the speed of the object when the time is 10 seconds. So this type of a question, I see most of you guys, you find it challenging, but it is not, guys. 10 seconds. If we check, this is 5. It is just like 5, 6, 7, 8, 9, 10, 11, up to 25. This one, it is a straight line, this one. Constant speed, meaning to say the speed that we see at 5 here, the speed that corresponds, the speed or the velocity that we are going to see here, let's say we do not know this one, we just call it x. The value here that we do not know, all right? Let me just put even s or even v for velocity. All right, let's hope this board is not going to stop again, guys. On the last question, if it stops this time, I'm just going to leave this question as it is. You answer it, guys. We'll see what's going to happen there. So let me just use the v for velocity, the one that you're used to. So what I'm trying to say there is, this one is a straight line, constant. It means you say same values. So 85, 86, 87, 88, 89, 10, up to 25. The velocity is the same. So the question here could have been asked as, calculate the speed of the object when the time is 11 seconds, when the time is 20 seconds, when the time is 6, when the time is 5. The answer was the same because of that constant. So it was, what can we say, an indirect question. The question that they were supposed to ask you here is, calculate the speed of the object when the time is 5 seconds here. That was the question. But you see now they try to avoid that. You're now used to those questions. But understanding of the diagram now is the part that is now needed. Are you in the same line? So you must understand the basics now. Same, here it's a straight line. It means throughout here, same values. It's just like, if we go back to the graphs, let's go back to the graphs. The line, if we are given, this is the x-axis, this is our y-axis. The line of x is equal to 2, y is equal to 2. Those lines, they represent the same thing. If we are given, let's say, x is equal to 1, it means that throughout that line, x will be equal to 1. Y is equal to 2. A horizontal line throughout, the y values, they are not going to change throughout. When I'm at this point, when I'm at this point, at this point, at this point, if I go back, I'm going to save same value of y. So that was the type of a question. So we simply needed the speed at 5 seconds. So how can we find the speed? We are given a deceleration. A deceleration of 4, it tells us what is happening. But remember, I told you guys, if you are given a deceleration and it is exactly what is happening, this is the 4 meters per square second. It means our acceleration is negative 4 meters per square second. Why am I talking about acceleration? It is the one that we use when you're calculating. Deceleration is ringotiudzira zviri kuitika panguva iyoyo. Formula yatinayo ndeye-acceleration, kwete deceleration. The formula that we have is for acceleration, the change in velocity, the change in speed over the change in time that we have there. It is for what? For acceleration, not deceleration. It is just like you want to calculate a profit or loss, the same concept. Yes, it's a deceleration. That is what is happening. What about if we talk about acceleration? We can see that we are decreasing. But as we want to talk about another way to say, how are we increasing? Guys, it's impossible. So in mathematics, that impossible part, we want to take it out. We can't say it's impossible. We introduce a negative. That is the concept. So acceleration, where you are not accelerating, it's a negative. The same concept applies when there is an acceleration like this. As you are going up, you can see this is an acceleration. I'm going up. It means my acceleration is what? Is positive there. So if the question now asks you to calculate a deceleration here, where you see its acceleration, it means your answer will be negative. Where we say deceleration, it's negative of acceleration. So when you are given a D, you put a negative to the acceleration. When you are given acceleration, you want to find a D, you put a negative to that. Guys, from one to another, just put a negative. From acceleration to D, put a negative. From deceleration to that one, put a negative. You're done. So, but on the calculations, what is it that you use? You use the acceleration. So acceleration, -4, is equal to the change in speed from where? Final minus, if we're talking about velocity, V2 minus V1 over T2 minus T, the change. Final, we started initially at 0. This is our initial speed. The final is where we are ending at 5 seconds. What is the corresponding speed? That is the one that we do not know. So I'm going to call it V. So that's V minus the initial, guys, at 0. The initial value for that speed is what? Is 50 over the change in time. T2 minus T1, 5 minus what? 5 minus which is 5. So we have formed an equation in V, where V represents that speed at 5 seconds, the speed at 10 seconds, the speed at 25 seconds, the speed at as long we are within this region, because it's a constant sum. So let's find V cross multiply. -20 is equal to V minus 50. So taking the minus to the other side, it was going to be what? A positive. So that's -20 plus 50, which is what? 30. Just like that. So the speed at this point is 30 meters per second at 5 seconds. Meaning to say at 6 seconds, at 7, at 8, at 9, at 10, same speed. So that is the speed at 10 seconds is what? 30 meters per second as well. It was that type of a question. You see how they play around with you guys. They know that you are used to these questions. Now find this one and this one. You just, okay. Change in velocity, change in that. They play around with you now. Calculate the distance traveled during the 25 seconds. During the 25 seconds, if we take, this is where we are ending. That's the whole journey. The whole journey. So that distance is simply the total area. The area of the shape. Area below the graph. So it's up to you guys. Are you going to work this as a triangle on its own? Then you move on. There is a rectangle here. You calculate its area, or you just combine it like this. This one as a rectangle, the whole of this one at once. This one as a rectangle. So you're working with a rectangle and a triangle. You combine them. Or you are going to, maybe you did not see that there's a rectangle and another rectangle. You subdivide them into 3. To say there's a triangle here, then there's a rectangle, this one. Then there's another rectangle here, this one. Guys, it's up to you. So it will be 1, 2, 3 areas that you're calculating. You combine them. Or you can use the trapezium concept, this one, as a trapezium. This part here, as a trapezium. Then you have got what? A rectangle. Guys, so many ways. I do not know which one do you want to work with. As for me, let me just put this way. I just found out another one which is much easier here. The rectangle, I'm just going to work with this one, guys. The rectangle, this one, the whole of this rectangle here. The whole of that rectangle. This one. Okay. I'm going to take this rectangle, which is from 0 to what? To 25 and from 0 to 30. Then the triangle there on top, which is it's gonna be from 0 to here. It's what? It's 5, remember. So here it's 5. From 30 to 50, that's 50 minus 30, which is 20. So that's a right-angled triangle. So distance, which is area, So our total distance, you just calculate as area of a triangle, half base times perpendicularity. It's a right angle triangle, this one. So half of the base times the perpendicular height, which is 20. Okay, plus the rectangle, like I said, length times with the whole of this one. So that's 30 times what? 25. Length times what? Length times width. So guys, combine everything. In this case, just try to combine everything, but you're going to obtain something like what? 800. This was gonna be 10. Half of this one is 10 times 50. 10 times 5, which is 50. Then you multiply this one, it was gonna be 750. Then you add, which was gonna be 800 meters. Is distance. Yes, you're calculating area, but it's distance, guys, meters. So I do not know which way are you going to consider there. Are you going to consider separate sections? How? But you must have the same answer there. So that was how you're supposed to attempt this typical question. So like I said, guys, let's do revise in as much questions and in our exams. Let us continue to revise in light as we are preparing for the exams which are ahead of time. And like I mentioned before, let us get in contact with Maths Guardiola so that we can have references to what we are using on our revisions. Are we talking about question papers, textbooks that you need for the subject that you are studying? That can help you a lot. Study with appropriate material. Don't just use any material just to say I'm studying. Use proper material according to your syllabus, and question papers also that can help. So let us do revise, guys, as many questions as we can till we meet again.